Welcome back to my office hours. In this video, let's talk about hydrostatic pressures and the hydrostatic forces derived from these pressures. Hundreds of dam failures have occurred throughout U.S. history. These failures have caused immense property and environmental damages and have taken thousands of lives. As the nation's dams age and population increases, the potential for deadly dam failures grows. Dam failures are especially common during heavy rain seasons. For example, in February 2017, heavy rainfall damaged Oroville Dam's main and emergency spillways, prompting the evacuation of more than 180,000 people living downstream along the Feather River and the relocation of a fish hatchery. Why? Besides many various reasons, one unavoidable fact is hydrostatic pressure and its resulting hydrostatic force. First, hydrostatic pressure. In a stationary fluid, all frictional and inertial stresses dissipate, resulting in a stress state known as hydrostatic. This state is characterized by the absence of motion. Hydrostatic pressure is the pressure exerted by a fluid in a state of equilibrium at any given moment, primarily influenced by the force of gravity. This type of pressure displays a direct proportionality with depth, measured from the fluid surface, as it corresponds to the augmented weight of the fluid when subjected to a downward force. Hydrostatic pressure can be computed using the following equation. Pressure equals to density times gravitational acceleration times the depth from the surface of the fluid to the specific location in the fluid. P equals rho gh in this equation. P represents hydrostatic pressure, rho denotes the fluid density, g is the acceleration due to gravity, and h signifies the depth or height of the fluid column. If we establish a zero reference point for pressure, and we consider h as the difference in height of the liquid column between the testing location and the zero reference point for pressure such as the outer space, we can express the previous equation differently to determine the absolute pressure concerning a vacuum. It is essential to emphasize that the density must remain constant in both equations. When dealing with a system containing two or more fluids of varying densities, any change in hydrostatic pressure must be addressed by dividing the fluid column into two or more distinct sections. Second, hydrostatic force. Hydrostatic forces refer to the resultant force generated by the pressure loading of a liquid on submerged surfaces. The calculation of hydrostatic force and determination of the center of pressure are fundamental aspects of fluid mechanics. The magnitude of the resultant hydrostatic force F acting on an immersed surface is expressed as follows. In this equation, Pc is the pressure at the centroid of the immersed surface, A is the area of the immersed surface, Yc is the distance measured from the water surface to the centroid of the immersed surface, ρ is the density of the fluid, and g is the gravitational acceleration. The center of pressure Yp is a specific point on the immersed surface where the resultant hydrostatic pressure force is applied. The center of pressure is calculated using the following equation. Ix represents the second moment of area or the area moment of inertia of the immersed body concerning an axis aligned with the free surface. The parallel axis theorem is employed for this calculation, as shown in the equation below, where Ic is the second moment of area of the immersed body about the centroidal axis. Considering a rectangle with a base b and height h whose centroid is positioned at the origin, the second moment of area with respect to the x-axis is determined by the formula here. The determination of the location and magnitude of water pressure forces on water control structures, including dams, levees, and gates, holds significant importance in their structural design. This information, along with the understanding of the hydrostatic force and its line of action, is crucial for designing various components of hydraulic equipment. Thanks for watching. Don't forget to leave a like or subscribe for future updates.